So this is section 2.1. We're going to be spending some time talking about linear functions. So equations of lines and also graphs of lines. My thinking is that a decent chunk of the stuff we're going to do from this unit will be kind of review for everybody. But we are going to talk about it just to kind of remind ourselves. So the standard, I shouldn't say standard because that technically means something else. The typical form of an equation that you usually see for a line, you've probably encountered this formula before. They say y equals mx plus b. I would venture to guess you've probably seen that before. And if you write it in a function notation, it's just, you change the y to f of x, but it's essentially the same thing. It's just a slightly different way of writing it. And so here we've got kind of an example here that, like, the distance traveled, you could start at, say, 250 meters, and then each second you're going an additional 83 meters. So the b value is basically it's the y-intercept on the graph, and it's basically your starting value. And then the m is the slope, which is basically how you are moving. It's the rate of change is sometimes what it's called. It's the rate of change. It's how you move to get to the next value. And so here they've got this table here. And what you will notice is that, like, you would start at 0, 1 second goes by. If you start at 250, you would add 83. That will give you the next value. And 83 is the slope. It's your rate of change. If you go another 1 second, you add an additional 83 meters. So you go from 333 to 416. If you go one more after that, you go from 2 to 3, and you've got 83 added to your distance there. And so the punchline with this, the kind of big takeaway, this is a constant rate of change. And in the future, we will look at graphs that do not have a constant rate of change. So the amount you go up by each step is a different number. But the thing about a line is that you have a constant rate of change. You're going up by the same amount each step of the way. If that happens, that's how you could tell from a table that what you're dealing with is a line. You're going up by the same amount from one step to the next. So you've probably, like I said, you've probably seen the linear function there. So you've got mx plus b. Here they have it written with f of x instead of y, but it's essentially the same formula that you've probably been using since high school, probably. M is the slope of the function. The y-intercept is the point 0, b. So the value b tells you where you start on the y-axis. It is the y-intercept. A function is increasing if it's going up over time. That should make sense, yes. So you read a graph left to right, just like you would read words on a page. So you would start on the left side, and if you're going up, that's increasing. That's another way of saying that it has a positive slope. If it's going down, it's decreasing, which is another way of saying it has a negative slope. And then there's a constant function where it's not moving at all. It's just staying flat. And that, incidentally, is a zero slope. And a little later, we'll talk about horizontal lines and vertical lines, but horizontal lines have a zero slope. They are flat. They have no slope at all. Kind of like the part of Illinois where I grew up. Very flat there. Anyway, let's see. So this is kind of just reiterating what I was saying before. So it's increasing if the value of m is bigger than 0. M greater than 0 is basically another way of saying positive. Because fun fact, positive numbers are greater than 0. Who knew? And then again, if m is less than 0, it's decreasing. That's another way of saying negative. And then m equals 0. That should be pretty straightforward. But so this is decreasing. This one's increasing. That one's constant. So we kind of already said that, but there it is. Okay. What else do we have here? So deciding if it is increasing, decreasing, or constant. So some recent studies suggest that a teenager sends an average of 60 texts per day. For each of the following scenarios, find a linear function that describes the relationship between the input value, and the output value, and then determine if the graph is increasing, decreasing, or constant. So the total number of texts a teen sends is considered a function of time in days. The input is the number of days, and the output is the total number of texts sent. So basically, this would be f of x equals, it's just going to be 60 per day. So, 60 times 1, that would be 1 day's worth, which would be 60. 2 days, you'd multiply by 2, so that would be 120. But so basically, it's going to be 60x is what it'll be. And that will be an increasing function because the number of texts that are sent just keeps growing and growing and growing and gets bigger and bigger and bigger. Part B, they say a teen has a limit of 500 texts per month in his or her data plan. The input is the number of days and the output is the total number of texts remaining. So basically how this would work, we'll call this g of x just to give it a different name. So essentially, the b value, the y-intercept, that's the starting value. That's how many you have to begin with. So this teenager has 500 text messages to start with at the beginning of the month. And then each day, the amount they have left is going down. And it's basically by 60. So that's minus 60x. So for instance, after 1 day goes by, they'd be down to what, 440? Because you're just taking away 60. And then if you take away another 60, that's what, 380 by the second day, something like that. Fun fact, this would be a decreasing function, which hopefully makes intuitive sense. Like, the number of texts they have left, that would be going down. That should make sense. And the thing to notice is that this right here is a negative number, which is why it's decreasing, as opposed to the last one where it was a positive number. So it was increasing. Part C, what does that say? A teen has unlimited number of texts in his or her data plan for a cost of $50 a month. The input is the number of days. The output is the total cost of texting each month. So we'll call this h of x. So fun fact, in this scenario, doesn't really matter how many texts they send. No matter what, they are going to pay $50 a month. So it's just 50. And that's it. There is no slope. This is a constant function. There is no slope because there's no value multiplied by x. It's constant. It will always be 50 no matter what. All right. So then this is just kind of describing the slope. So some of these ideas, some of this should maybe be stuff you're familiar with. Some of it, the notation might be kind of new to you, but my guess is you've probably heard of this. So the slope m, that's the rise over the run. That's one way you could describe the slope. There's also this formula here. If they give you coordinates of points, this is a handy formula you can use to calculate the slope. You do the second y minus the first y on top, find out how much the y's have changed. Then on the bottom, you do the second x minus the first x, find out how the x's have changed. This is probably kind of a new one for most of you because here we're using the function notation, but it's basically saying the exact same thing as this right here. You know, f of x2 is just another way of saying y2, because f of x is the same basically as y. And if we're talking about a picture, the change in y is basically your rise, how far you move up or down, and then the change in x is how far you move sideways. So as like a picture, that's kind of an example of what the slope would look like. So we've seen this before. So this is probably the big formula that you want to know. And again, my guess is you've like seen this formula before, but so hopefully this is something you all can handle and have seen in days gone by. But that's the formula to calculate a slope. You do the second y minus the first y, and then underneath you do the second x minus the first x. All right, so f of x is a linear function. It has 3, -2, and 8, 1. Those are points on the line. Find the slope. And then they also ask us, is it increasing or decreasing? So let's find the slope first, and then we can decide based on our answer if it's increasing or decreasing. 3 is going to be x1, -2 is y1, x2 is 8, y2 is 1. I think it's worthwhile to just jot down, get all my ducks in a row so I know which numbers are which. So what is this? You've got y2 minus y1 all over x2 minus x1. The second y value is a 1. You subtract the first y value, which is -2. Second x value is an 8. Subtract the first x value, which is a 3. 1 minus -2 is the same as 1 plus 2, that's 3. 8 minus 3 is 5. And there you go. That is your slope, 3 over 5. It's perfectly okay for that to be a fraction. Nothing wrong with that. This is positive, so that is going to be increasing. Positive slopes are another way of saying it is increasing. What else do we have? Here's another one. We've got 2, 3. So this is x1, y1, 0, 4. That's x1, or I'm sorry, x2, y2. Find the slope. So we're going to do much the same as what we just did. Second minus first, 4 minus 3. Second minus first, 0 minus 2. 4 minus 3 is 1. 0 minus 2 is -2. So that is m equals -1/2. That is going to be decreasing since that is a negative slope. So negative. Anyway. Oh, let's see. So again, hopefully that kind of stuff is just a rehash for everybody here, but let's see what else we have. The population of a small town went from 1442 to 1868. Between 2009 and 2012, find the change of population per year. If we assume that the change was constant from 2009 to 2012. So I mean, some years it may have been bigger, some years it may have been smaller, but we're going to assume like we're just going to split the difference and say it went up by the same amount each year. So if you were to write this as like coordinates, so you would do the population per year. So basically what that means is this population needs to be Y, because that's the change in Y. Years needs to be X, that's the change in X. So we're gonna do X is the years. So in 2009, there were 1442 people. And in 2012, there were 1868 people. So we've got X number 1, Y number 1, X number 2, Y number 2. So let's find the rate of change, the population change per year. So what is that? That's 1868 minus 1442 over 2012 minus 2009. Let us figure out what 1868 minus 1442 is. That happens to be 426. 2012 minus 2009 is 3. 426 divided by 3 is the number 142. So then the rate of change is 142 people per year. And that is increasing because it is positive. And then intuitively, that should make sense because, as you can plainly see, the population went up between those 2 years. So it would make sense that it would increase, yes. So there you go. That is that one there. Let's see what else we have. So there are other forms of equations of lines. You're probably most accustomed to y equals mx plus b, but that's not the only one that's out there. There is another one that's a thing, and this is known as point slope form. And this can be handy just because you can write an equation of a line based on any point they give you, not just the y-intercept. So you may not know the y-intercept, but if you know any point on the line, you can just use this formula and it'll work just fine for you. And so x1, y1, that is the point that you know. You know one point, which is x1, y1. And then the slope is still m. That's the same as it has been. So how would you use this? They say write a point slope form equation of a line. The slope is 3, so that's another way of saying m equals 3. The point is 6 negative 1s. That means x1 is 6, y1 is negative 1. Then they say rewrite it in slope intercept form. So Fun fact, writing your answer in point slope form is a perfectly legit thing to do. And if they don't tell you to like write it in a different way, you could just put the numbers in and call it a day. Here they're having us write it in point slope form, and then they also want to change it to y equals mx plus b. So we're kind of doing both, but so what's the formula here? Y minus y1 equals m parentheses x minus x1. So let's see here. So we're going to say y minus -1. That's y1. M changes to a 6. And then inside here, we're going to do x minus x1. Actually, no, sorry. 6 is not the slope. Hold on. 3 is the slope. That's what m is. 6 is the x1 value. There we go. Y minus -1 is another way of saying y plus 1. Yes, we know that, I'm sure. So there you go. That is the answer in point slope form, which, like I said, that is a legit way to write your answer. It kind of just depends on what the question asks you to do. If you want to make it slope intercept form, that's not too terrible. You've got your parentheses here. You might see that and say, this is a job for the distributive property. Da, 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 da. And what do we got? We got y plus 1 equals 3x minus 18. Multiply those both by 3. Subtract 1. And that's what? 3x minus 19. And that is slope intercept form. And again, slope intercept is the name of the formula you're probably more familiar with. Y equals mx plus b. That's what it's called, is slope intercept form. Okay. What else do we have? Write the point slope equation with a slope of -2 that passes through -2, 2. Then rewrite it in the slope intercept form. All right, so this is pretty much the same thing we just did. M equals -2. X1 equals -2. Y1 equals 2. So y minus y1 equals m parentheses x minus x1. So let's see, y1 is 2. M is -2. And then that's going to be x minus -2. Again, subtracting a negative is going to be the same as adding. So your point slope form is going to look like this. That's point slope. They do tell us to go ahead and change that to slope intercept. So again, we'll break out our distributive property here. Y minus 2 equals -2x minus 4. Add 2 to that, and you get y equals -2x minus 2. And then that is slope intercept form. Okay. Let's see what else we have here. So writing linear equations with 2 points. So they say write point slope form of a line passing through 5, 1, and 8, 7, then rewrite it in slope intercept form. Okay, so here we're kind of going to do both things at the same time. We have a slope formula, y2 minus y1 over x2 minus x1. And then we've got the y minus y1 equals m parentheses x minus x1. So those are the two formula we've been dealing with. And we're basically going to use both of them together in the same problem. Say what? I dare say that is cray cray, but we can do this. It will be okay. All right. Let's see here. So you got x1, y1, that's your first point. You got x2, y2, that's our second point. So first off, what we're going to do is we're going to calculate the slope. So what's that going to be? That's going to be 7 minus 1, and then 8 minus 5. 7 minus 1 is 6. 8 minus 5 is 3. 6 divided by 3 is the number 2. And then check this out. This is going to blow your mind. We already have x1, y1. They're both right there. And then now we have m. So now, I don't know, maybe that seemed anticlimactic to you. But we already have x1, y1. How about that? So we're going to take this m, and now we're going to put them into this formula here. What is this? Y minus y1, which is 1. The slope m is a 2. Okay, very nice. X minus x1, x minus 5. Okay. So they say write the point slope form. Okay, well, there you go. That's the point slope form. Like always, they do want it in slope intercept form too, but point slope form is that. Let's see, let's break out some distributive property here. Multiply a 2 right there. What is that? Y minus 1 equals 2x minus 10. And we will add 1 to that. And when you do, you get 2x minus 9. There you have it. That is the slope intercept form of that equation. Okay. What do we have here? Okay. Write the point slope form of equation that passes through those points. -1, 3 and 0, 0. All right, well, what is this? This is x1, y1. This is x2, y2. We shall find our slope. 0 minus 3 all over 0 minus -1. 0 minus 3 is -1. 0 minus -1 is the number 1. And if you divide that, you get -3. Then let's see. Y minus y1. Y1 is 3. Let's see. M is next. X minus x1, which is -1. So you have y minus 3 equals -3 times x plus 1. That is point slope. And then break out your distributive property. Y minus 3 equals -3x minus 3, and we add 3. And lo and behold, those will cancel out. So what's left is y equals -3x. And that is slope intercept. So again, if you know the formulas, this should not be too bad. The catch is you want to know those formulas. All right, we got one last example, and then we will call it a night. So what is this here? If f of x is a linear function with f of 2 equals -11 and f of 4 equals -25, find an equation in slope intercept form. Okay, so what this means, what goes in the parentheses is the x value. What the function spits out is the y value. So really, this first thing is 2 comma -11. That is the point that that describes. In a similar vein, this is the x value, which is a 4. And the number it spits out is negative 25, the y value. So this is just the point for negative 25. And when you write it that way, then what you're going to do is exactly the same as what we had been doing. So it may look different at first glance, and you might look at that and you'll be like, I don't know what to do. But it's okay. Just take a deep breath. It's really just the same thing that we have been doing. So we've got x1, y1, x2, y2. The slope is negative 25 minus negative 11 over 4 minus 2. Negative 25 plus 11, which is what that's the same as, that is negative 14. 4 minus 2 is 2. And if you divide, you get negative 7. Then what? So we say y minus the y value, negative 11, equals the slope, negative 7, and then x minus 2, the x value, from point number 1. They tell us to just do slope-intercept form. They're not bothering with multiple forms here. Y minus negative 11 is y plus 11. You distribute that, you get negative 7x plus 14. And then if you subtract 11, you shall get your answer, which is negative 7x plus 3. And that is the solution. And with that, we are done with section 2.1. All right, so we will stop there for tonight.